Okay, folks, so we're going to use this important information right over here to find really critical values of our parabola. Okay, so what we graph is called a parabola. Let me just zoom back up here for just a second. This blue shape is called a parabola. This is called the quadratic equation or quadratic function. Okay, let's put that in our notes right now that I'm thinking about it. So this thing over here is called the quadratic equation. Oh geez, quadrat. Oh my goodness. Come on, Nelson. Quadratic. Let me try again here. Hold on. Quadratic function. And this over here is called a parabola. Parabola. Okay. So what we're going to try to do is take this quadratic function over here and we're going to try to graph the parabola for it. Its graph. What does its graph look like, right? So when it says graph the function, well, we know it's going to be that shape that we saw up above. But I want to explain a couple things. Well, to find the axis of symmetry, you need to do a formula that involves the I didn't really want to put an equal there. I wanted to put axis of symmetry. Axis of symmetry. Okay. You need to put a formula down that looks like this. X equals the opposite of B over 2A. Now, when I look in the book, they don't explain where the heck the formula comes from or anything like that. It comes from what's called the quadratic formula and completing the square and a whole bunch of stuff that we don't really want to get into right now. But I do want you to have some feeling for like, wait a minute. So I just take the B value and I divide by 2 times the A value, and then I take the opposite of that sign. That's what this is really saying over here. So let's try it on this one. I go X equals, the B value was 6, right? So I put a 6 in here. Or I put my negative sign. You can put the negative sign out front, you put it up top. Doesn't really matter where you put that. Then I'm going to put 2 times whatever the A value is. The A value is negative 3, right? So let's see, what do I get? I get negative 6 divided by negative 6, negative 6 divided by negative 6. Well, it should have an axis of symmetry at 1. So if I go over to x equals 1 and put a vertical, oh geez, stay on the line there. Put a vertical line down, try to make it nice and straight on your graph paper. Okay, that's our axis of symmetry. Axis of symmetry. So I wanted you to see that really works, or have some feeling for why it works. So I'm going to switch back over to my Desmos program. I've got ax squared plus bx plus c in there. Now let's focus on the c value for just a second. Remember how the c value is not in our formula. It's just the opposite of b over 2a. So if I change the c value, it doesn't change where the axis of symmetry is located. Do you see how the c value just moves the parabola up and down? The axis of symmetry would still be right in here somewhere, right? Let's change the a value for a second. If I change the a value, you see how the parabola gets wider and wider and wider, and the vertex is moving. The axis of symmetry is moving. Now, if I move it all the way upside down, notice this. Now it's going downward because our a value is a negative value. So just have a feeling for the leading coefficient determines whether the parabola is going up or whether the parabola is going down. That's really important information. Okay, so when I look back at my parabola here, I've got a parabola that's going to be going down. So we're expecting the parabola to do what kind of the parabola up in our Desmos example did, like up here with shooting a basket. It's going to look like that kind of parabola, right? If the a value over here was positive, then we would expect our parabola to go up. But my main focus, let's not lose track of our main focus. Notice how the formula doesn't have a c value in it, because the axis of symmetry is completely independent of what the c value is. The c value just moves the parabola up or down. So the axis of symmetry is going to stay in that same spot. It's all dependent upon the a and the b value. Let's see what the b value does. That's interesting. See how the b value moves where the axis of symmetry is located? So that is really important information as well to determine where the axis of symmetry is. So make sure you have that formula down in your notes. This is the formula we're going to use to find the axis of symmetry. So after you do that, after we know it happens at x equals 1, right, somewhere along this line is the vertex, we need to figure out what the y value is. So we take the 1 and we plug it in to our function over there. So let's put a little note down here. Plug x equals 1 into our function. Okay, so that's what I'm going to do next. So first we did opposite of b over 2a. Now we're plugging x because our answer was 1. We're going to plug 1 in to our function. So I go negative 3 times 1 squared plus 6 times 1. I don't want to mess any of this up. Minus 4. All right, so I think I got the 1 plugged in there. So I end up with negative 3 because 1 squares 1 and times negative 3 is negative 3. Then we got plus 6 more, minus 4. Let's see, where's it going to be? That would be 3, right? Positive 3. And then if I add 3 to negative 4, I get negative 1. So if I go over 1 and I go down 1, my vertex should be right there. Let's put the ordered pair down. 1 comma negative 1. Gosh, I hope I didn't make an arithmetic mistake. Somebody's going to point that out in class. If I did, they're going to, I don't know, they're going to make fun of me. So anyways, the next thing they suggest you do in the book is you find the y-intercept. I like that suggestion because you plug 0 in for x. Plug x equals 0 in. Okay, so here we go. Y equals negative 3 times 0 squared plus 6 times 0 minus 4. Hey, do you notice any term that has an x in it goes to 0 because we're plugging zeros in for the x's, right? So really it's just the c value, negative 4. That tells you the y value of your y-intercept. So if I go 0, negative 4, if you want a real shortcut to that, you just go straight to the constant that's at the end, and that's going to be your y-intercept. So let's go down to negative 4, okay? And let's put down a dot. That's my y-intercept down there. Let's see. It says use symmetry to find more points. Well, guys, look. If this point is 1 over, our y-intercept is 1 over from our line of symmetry, there's got to be a matching point equal distant on the other side of our axis of symmetry. So put another point right there. We know that point 2 comma, what is that, negative 4 has to also be on our parabola. Okay, so let's look at something else. If I go over 1 and I go down 3, 1, 2, 3, it's the same as going over 1 and down 1, 2, 3. That's kind of interesting information, isn't it? That's how line of symmetry is going to work. Do you notice the 3 over here? Right? So that we're going to get to that later. That's kind of an important idea that we went over 1, we went down 3. All right, let's see. Do we need any more points to find this parabola? Ugh. At this point, I think what I'm going to do is I'm going to just try to graph my parabola. It's pretty steep. I don't want it to look like it comes to just a sharp point up here. I want it to look like it kind of bends through that point, but it's pretty dang steep. And I'm trying to make it look symmetrical on either side of my axis of symmetry. So if you need to find more points, like let's say you wanted to find another point, you could take 3 and you could plug 3 in, like in for x, right? Plug 3 in for x to get it more accurate. You know how like I'm saying, geez, man, I'm having a hard time, getting it to look like it is nice and symmetrical. So you could plug some more points in. So you go y equals negative 3 times 3 squared plus 6 times 3 minus 4. Let's see how hard this is to do. 9 times negative 3 is negative 27. That's positive 18, and then minus 4. Negative 27 plus 18 is going to be negative 9. So I got negative 9 minus 4, so negative 13. Well, see, that's not super helpful because my graph only goes down to negative 7. So, it'd be like way the heck down here somewhere, right? And then you could continue on your graph. You're trying not to make it look like a straight line here, right? It's going to be curving down. All right. Hey, I've connected the points already. That's your last task, to make it look nice and smooth. I'd put arrows at the end. Okay, so put arrows on the end. Put arrows on the end to represent the end behavior on the ends. Okay, so those are the steps we're going to follow to graph our parabolas. I just want to kind of check to see if my parabola makes sense here. So I want negative 3, 6, and negative 4 for my values. Let's try it out. I can just type over here and go negative 3, and then this was what, 4? And then this was 6, I think, wasn't it? Let me check. Let me check here. Hold on one sec. Was it negative 3, 4? Oh, wait. It was 6 and negative 4. I got to switch that around. This was 6. I was worried because, see, my graph wasn't coming out right. And then this was -4 over here. Whew! Thank goodness. See, my vertex is right there. Where's my axis of symmetry? X equals -1. No, it was x equals +1, right? X equals +1. And then I could change this graph into a dashed line there, or make it look like that. So that's my axis of symmetry going right through the middle. Now let's check it out. Is it going through a y-intercept of 0, -4? Sure is. Do we have a point over here at 2, -4? We sure do, right? So we can graph it without Desmos's help. Thanks for watching my video. I hope it's clear how to follow these steps right here to graph our parabolas. Okay? Good luck.